So I'm going to talk most about Oak Ridge, but I thought I would say one more thing about ECI, a slide I neglected to show this morning, and that's that the fact that the project is going to be centered at Oak Ridge, meaning that that'll be where we'll hang our ECI project sign, so to speak. The leadership team will be from various DOE labs, but this is the latest organizational chart, and there you see the four principal technical areas: application development, software technology, hardware technology, exascale systems. There'll be a lot of project management and operations responsibilities that'll lie with Oak Ridge, and you see we have lots of ideas about what these councils might do with regard to ECI based on kind of past projects and programs, but I thought I would show that initially because that's a very exciting development for, I think, the DOE lab community in general, certainly for Oak Ridge, where we're going to get a chance to essentially stand up a new project office. And so there may be some shifting of heads, myself included, in the near future. So I'd be happy to talk more folks offline, but this is a slide that Steve Binkley showed in the July ASCAC meeting. So I neglected to show that this morning. So that's all I'm going to say about ECI, unless there are questions. But I'm going to move to an updates at Oak Ridge. So, and actually Chris Fuson is here, and maybe he can correct me if I say anything wrong or from Oak Ridge. He sits at the Oak Ridge Leadership Computing Facility. And looking at past presentations from Oak Ridge folks, the last few meetings, I think you've seen some of this before, so I'll hurry through the material and get to some new developments. So that's the Oak Ridge Leadership Computing Facility. Again, there are two leadership computing facilities for DOE Oscar program, one at Argonne, one at Oak Ridge. So OLCF, as we call it. Organizationally in Oak Ridge, it sits within the directorate that I'm in, and it also looks like what we call a division as well. And so key leaders that have been in front of this group, just to point out, Jim Hack is our division leader for the division known as NCCS, within which OLCF resides. Buddy Bland, who's been here a lot, I think most of you probably know, is the project director. Kathleen Baldwin is the deputy project director of OLCF. She's going to be moving over into the ECI project as our I guess lead project manager is how I would put it. And the OLCF just recently stood up a new group, data. I'm looking at Chris. Advanced Data and Workflow. Did I get that right? Yes. A data science group. In effect, we're seeing more and more applications and more need to have card-carrying data scientists, and we're standing up a new group. Jim Hack just announced this, in fact, today. So that's a new development for the OLCF, and it's just sort of recognition of what we're doing already as well as what we want to do moving forward. So I'm going to show some slides that Buddy Bland just put together. So again, as a reminder, since the leadership computing facilities were stood up in 2004, OLCF has really enjoyed a fairly rapid growth and rapid pace within the Oscar program with regard to systems. There you see kind of a history. I personally came to Oak Ridge in early 2006 when Jaguar was 23 teraflops. So seen myself and been a part of this center as well for 4 or 5 years, but I've seen myself the rapid growth, and in large part due to I think what we currently benefit from a lot of very talented leaders and managers as well as staff. So again, looking forward, I'm sure everyone's heard about and know a fair amount about Summit and the Coral arrangement, but I want to say a little bit about that and kind of what I see from my perspective. Currently, Titan is our system on the floor. It's the number 2 system in the world, at least from a LINPACK perspective, which we may not necessarily like, but I'll say a little bit about Titan and kind of what's happening on that system, as well as where we are with Summit, and perhaps defer to some of my colleagues in the room here for details. Again, a reminder, Titan's still in full operation, and one thing that people may not appreciate or know is these centers go through fairly rigorous operational assessments every year. And the operational assessments are really conducted by an external group of users that gives very candid feedback on how the facility is operating. There are certainly a lot of metrics that are used for in this case, Titan, like system uptime, system availability, utilization. All that information is gathered and tracked carefully and used as a part of the assessment process. All the facilities, NERSC, OLCF, and ALCF go through this assessment. It really is a very good process. The point is, this last year's assessment really came back with some resounding, very positive feedback for the OLCF, and that's always been the case, but this year in particular was really nice, and be happy to share with you some of that information. Susie and others were a part of that. Anyway, there's the speeds and feeds. I'm not going to belabor those numbers, just kind of remind you. And I believe this group has heard about the Coral collaboration between Oak Ridge, Argonne, and Livermore. And you know, from my perspective, this was not really necessarily a fortuitous arrangement, but all three labs really were looking at procurements in their various programs at the same time and came together. And there you see the approach and the benefits. And in talking to Buddy Bland in particular, you know, it's just been a great partnership that has really allowed, I think, the labs to work together more collaboratively, exchanging best practices, lessons learned, and maybe ways we should have been doing already. And other labs, Manny Vihil's here from Los Alamos, and there's an Apex arrangement there. And so I think we're figuring out how we can work together and meet our own programmatic and institutional needs. So there you see the RFP requests, and Livermore issued the one RFP. And from my perspective, Livermore does a very good job in the RFP process. They historically really have kind of taught the other labs how to go about that. So from an Oak Ridge perspective, you know, we benefit a lot, you know, by learning from them. But in this case, the RFP being issued by Livermore made a lot of sense. They had really a lot of best practice approaches with regard to how this is done. And so, two architectural paths chosen. Oak Ridge and Argonne actually chose different paths for very different reasons, and that's the Aurora and the Summit systems, and you probably heard about them. But I'll have a few slides here on that. So anyway, I'm not going to read all the points. Other than that, this collaboration has really worked well. And now what's occurring is on a quarterly basis, formal reviews are being held with the various vendors to see how things are coming with regard to their schedules. And you know, certainly daily, if not weekly, conversations are going on. I think the Coral quarterly review, I'm looking at Susie, was just last week, the latest quarterly review. And so all three labs come together and basically hear how things are going or not going with regard to these procurements. Again, Summit and Aurora are the two systems really in the DOE Oscar space, the leadership computing facilities. You've probably seen this before. Essentially a hybrid node system with the Summit and then the mini core system with regard to Aurora. And both of these systems have, depending upon funding, you know, I think nice growth paths beyond their sort of initial targets. And I think I have that on the next few slides. So on the Titan system, again, we will continue our hybrid CPU, GPU architecture. From an application development point of view, there's a lot of very exciting things here. There's a lot of scary things here too. So we're going from about 19,000 nodes down to 3,400 nodes. Okay, so we're not really, nor have we been really, frankly, since I've been at Oak Ridge, our systems have all kind of been about 19,000 nodes. So we've just been beefing up the nodes. This is a major reduction. So we got 3,400 nodes, and now we got very, you know, essentially, yeah, there we go, 40 teraflops on a node, and kind of a teraflop and a half or so of memory. And so, you know, the good old days, we heard that I think earlier today, of byte to flops being kind of 1-to-1 is really not here. You know, this node has a lot of very interesting aspects, but the memory to flop ratio is admittedly, you know, sort of 3 to 5%. So there's going to be some challenges there with regard to trading off memory for compute. Like some of the other systems coming online, there's a lot of interesting potential with the NVRAM. ability to configure it for different, in different ways for different applications. Certainly, another example is the burst buffer at the Los Alamos Trinity system. From an applications perspective, this is not necessarily just extra memory, which is always nice, but they're sort of thinking about maybe equation state tables or data tables or doing out-of-core things. In other words, I think each application has different ideas about what to do with the NVRAM and the burst buffers, and I think this is an interesting, frankly, research area in terms of what makes the most sense from an application perspective. Let's see. The NVLink is a very promising development. We really like that. Really has helped, I think, potentially ameliorate what was before kind of a bottleneck. Summit compared to Titan, I believe that Charek Stratzman showed this the last HPC User Forum when he talked about our CAAR application. So I just thought it would be good to show this again. It gives you the comparison of Summit and Titan. And so we're seeing lots of really fairly dramatic changes with regard to the memory, and we're going to a different interconnect topology. I personally am very fond of a fat tree. Like to do a lot of implicit sort of computations in my own background, and fat trees are very helpful in that regard. If there are any questions, I'll just keep moving. The peak power consumption is really staying kind of right there, and that's in large part due to the GPUs certainly, but we've been able to keep that fairly constant at this time. Charek Stratzman heads our scientific computing group in the Oak Ridge Leadership Computing Facility, and I think he talked about this last time. Each of the facilities has what's called, I'll call it a science acceptance or an early science program, whereby application teams can apply for early access on these systems and make the case for utilizing the system in a large way, in this case in more of a capability way. Also, in other words, what kinds of early science problems can we target, but also what's my software path to get there and where do I need help. And so this has actually become a very nice process over the last, fairly formal process over the last 4 or 5 years, where each facility has its own early science program that actually has real money behind it finally, meaning the DOE Oscar program typically commits 1 postdoc per application to partner with, so in other words, each application team that is selected is able to hire a postdoc to come in and help them with these early science activities. And so the list of CAAR applications, and again, CAAR is the Center for Accelerated Application Readiness, was announced recently. I believe Charek announced this at the last meeting, and just to give you an idea of the breadth of codes and application areas, you sort of view for yourself. A couple of interesting things to note: these selections aren't restricted to U.S. projects and to DOE mission space project only. The selections are made with approval and concurrence by the DOE Oscar office. But you see some international representation. I'm guessing for the next round of this for Summit, you're going to see some other, maybe more what I'll call non-traditional apps, data analytics, data science sorts of applications. What we see here are more traditional HPC applications that are all going to deliver, we think, very impactful science. But I think you're going to see a different kind of mix of things moving forward. So in preparing for Summit, we're currently going through facility upgrades, and if you've ever come to Oak Ridge, it seems like this one road, and I forgot the name of the road, Susie, is in a constant state of destruction. We're always putting new transformers and new bus bars and all kinds of things there, but currently preparing for Summit, and it will not sit in the same floor that the Titan sits. It'll sit nearby, occupy obviously a lot less floor space, but those those facility upgrades are on schedule. And again, you can talk to Buddy Bland if you have any questions, but we're already moving out in terms of preparation. The INCITE program is still the major allocation program for these leadership computing facilities. There, about 60% of the core hours are allocated through the INCITE program. And there you see the kind of ratio of requested versus awarded. I don't know what a good ratio is. If the request is less than what we can award, that's a problem. This is kind of 3 to 1. 10 to 1 may be bad. It may indicate we really are poor in our ability to service the user base. It could be good in that more and more people have a need. But there you see the kind of the history. The INCITE program for next year, I believe, is looking to allocate something like 6 billion core hours, and they're currently in the throes. The facilities work closely with in peer-reviewed subject matter expert committees in making these selections, and so they're currently, I think, in the process of finalizing those selections for 2016. As a reminder, these allocations are typically multi-year with sort of year renewable, meaning if you don't use any hours, you're likely to not get your second year, okay? So that's probably the first order metric. These allocation cycles tend to be sort of 3 to 5 years. I'm looking at Susie, make sure I got that, yeah, I got that right. One other point is as we move into exascale and we look at a broader array of applications, it very well could be that the INCITE program will change and adapt accordingly. There are certain sets of requirements and targets that the INCITE program is looking for, and I'm speaking as Doug, not Oak Ridge. Okay, I've had discussions with DOE Oscar program about potentially looking at the INCITE program and rethinking it a little bit with regard to the allocation process, given that I think we're going to have a kind of interesting different spectrum of applications. And so that's something. The INCITE program has been very successful. I think it's a model. I think the PRACE program follows a lot of this. In fact, I help review a lot of the PRACE projects, so I get a good sense of what that program looks like. And I think the INCITE program has really been a model in that regard. So I'm not suggesting it needs to change in a major way, but I think it needs to sort of adapt as technologies and application needs change. And Susie is a big part of this program, the Excel program. I just wanted to put in a plug that we have seen more and more industry usage and more industry feedback, return on investment, so to speak, on Titan. And in fact, the industry projects continue to grow year by year. And Susie's probably briefed you all on this, but it's really, I think, it's being seen, at least across the DOE lab complexes, that either have user facilities or want to move in that direction. This program is seen as a model, and other labs are very interested in emulating it. And so we're very likely going to, now speaking with my ECI hat on, pull Susie into that gig and have her figure out the how to best work more closely with industry. So we're lucky to have her right here. In terms of some science output, I'll just say a few things. One could look at the applications in various spaces like geosciences, energy, and fundamental sciences. Certainly one of our poster apps on the OLCF is climate, and in this case, the relatively new DOE ACME program, which is taking the CSM model kind of into the future. There's a lot of energy production, energy transmission, energy generation sorts of applications, and the last 5 years I've been working myself on a project known as CASTLE, which is about modeling nuclear reactors, and so that would fit in that middle column. And of course, there's a lot of fundamental science here as well. And so Buddy did a nice job in sort of piecing together the various applications. And I'm not going to go into any of the details here other than to say that there is a fairly broad spectrum of energy generation applications represented right now on the Titan system. And I think we're going to see those grow, and both in breadth and depth. certainly as we look at the exascale possibilities, every one of these areas has made, I think, a pretty good case for application development and delivery of solutions on the exascale systems. And then on the transportation side, this is where I think we're going to see more and more growth, in particular on the manufacturing side. I've been looking at that, and I think there's a real need and interest to be able to simulate, to develop high fidelity simulation tools for additive manufacturing. And so I think we're going to see some interesting new applications in that space. And certainly we're seeing more and more related to energy storage. The battery hub is a good example at Argonne. And so I think on the transportation side, there's some interesting possibilities. And these are currently existing applications. I will say that we've been talking some with the EERE Vehicle Technologies Office, and I think something like an integrated virtual car application is quite possible and very interesting as another area to focus on moving forward. And again, climate science, grid, superconductivity, or strongly correlated materials have a big presence on our system. Carbon capture and storage, in particular the CCSI, the Carbon Capture Storage Initiative at NETL, has a nice simulation package that I think is going to be continue to be a consumer of resources at Titan and other sites. Let me talk in particular about a fairly new development, and that's something we call CADES. And there you see it's actually a destination in the Smokies, CADES Cove. And I guess I'll credit my boss, Jeff Nichols, maybe for coming up with that name. But, you know, it's got a nice geographical representation in our neck of the woods, as well as an acronym. And so this has been an ongoing activity, a new data center, if you will, for a couple of years. And right now, the focus is more internally in providing an environment, an ecosystem for Oak Ridge staff to do data science and data analytics. Arjun Shankar is the center lead. We do envision CADES as growing and becoming more of an integral part of the DOE Oscar program, and maybe more integrally part of the OLCF with regard to what we think will be happening in the future, namely something like a science data facility, or SDF as Steve Binkley calls it. We see something like that as quite possible. And so CADES has been an ongoing effort for a couple of years, and it continues to grow. And I want to say a little bit about CADES and encourage, if you're interested, I could give you this CADES director, Arjun's contact information. So the CADES mission is really, initially, it was more about the infrastructure needed to do this kind of science, okay? But it's really growing to where the center itself would like to, in partnership with the OLCF, really provide data science solutions. So have data science staff as well as the technologies, meaning hardware and software, in one ecosystem. And so this is the current mission for CADES. And the idea here is to stand up an array of flexible toolkits and services. And many of these did not really exist at Oak Ridge a few years ago. And I have another slide that gives you examples of the technologies. But CADES right now is partnering with some of the data experimental facilities at Oak Ridge, Spallation Neutron Source as an example, the Center for Nanomaterials, in understanding their imaging needs, their data needs, and using this technology and the toolkits and the ecosystems as well as the staff to help some of the projects internally. So it's been more internal looking to date, but we see it expanding and moving out externally later in the next few years. So some of the CADES systems on the floor, I'll let you look at that. But for example, we have a Eureka system for graph reduce, Hadoop systems, and we're looking at the OIC. I'll just point out at the very bottom, that's a sort of an Oak Ridge term for institutional computing, meaning we provide a lot of compute services in our directorate. for smaller scale cluster capacity sorts of resources. And that's from an institutional investment. CADES will subsume all that, and all the sort of local institutional computing will be part of CADES, but we're going to have the data science and data analytics software and hardware all part of the same system, okay? And having it be able to integrate with and talk with Titan and the OLCF is also instrumental. So that's an idea of kind of where we are now, and this ecosystem is growing by leaps and bounds, frankly, every year. So here you see kind of an idea. This is sort of the way CADES is currently operating within Oak Ridge. Namely, you see SNS projects, ARM projects, ACME projects, CNMS projects, Castle, the program I used to run. These are principally Oak Ridge or Oak Ridge collaborative projects. So CADES is first working locally, kind of understand what the center can do to help the data science needs locally, and then we're working to expand and look more external as well. So it's a fairly heavy laboratory investment in this center, as well as projects. In the one I was involved in, Castle, invest into CADES in either the infrastructure or staff or both. So it's really viewed as a birthright model. If you're an Oak Ridge staff, you have access to this data center or this data science center, as well as projects are encouraged to collaborate either in funded or non-funded ways. So this CADES is still evolving, but I wanted to expose it to this group and get your thoughts and feedback. We certainly have been talking with our DOE sponsors about what we want to do and why, and feel like we'll be the center will enjoy some growing support in the future from more and more DOE sponsorship. And examples of current partners for CADES, and you see that Arjun Shankar and his people have reached out not only internally but also externally to begin to interact with external customers and stakeholders. With that said, I believe I'm done. So if there are any questions or comments, I'd be happy to take.
Doug just had a question. I understand you got a good relationship with the University of Tennessee as well. Mm-hmm. And this is a total side question related to our NSCI discussions earlier. But do you have, wow, that's loud. do you have programs or relationships where you can dedicate some resources for the undergrad engineers or the data science or something? Is that something you guys have going on?
Yes, and that would likely occur principally through what we call JICS, which is our Joint Institute for Computational Sciences, joint meaning joint with Oak Ridge and UT. And again, for the Texas people here, this is the other UT. Yeah, a little different color, a little different logo.
I'm from Tennessee, so I can say that.
Okay. So Tony Mezzacappa is our JICS director. He is organizationally, he's a joint faculty. He's a University of Tennessee employee, and we essentially contract him part-time. That building is right on our campus, and that's where a lot of our University of Tennessee interactions occur, kind of through that center. But there are a lot of joint centers across Oak Ridge with UT. So we have a very good relationship with UT.
Yeah, we're asking the question in the context of growing the ecosystem. So it's something we can revisit later. But.
Okay.
For the current system, how do you determine core hours when a function of a GPU is very different from a core?
That's a very good question, and I personally think that unit of currency is, maybe makes no sense. Okay, it's a tough one, but right now, one node hour, okay, on Titan is 30 core hours. Okay, so you get charged for, and that's 14 on the AMD, and I think it's 16 is the number that you're charged for the GPU. And I think that was arrived at, and I wasn't involved in that calculation, but it was arrived at by looking at sort of equivalent flops in both areas. So if your application does not use the GPU, okay, what that means is, you're getting one don't want to say this, $1 out of your $2 allocation, okay? In other words, if you're awarded 100 million core hours and you don't use the GPU, you really only are using 50, you really only can use 50 million. And so there is a, certainly a value proposition there in terms of motivating people to access the GPU. What the currency will be moving forward, I'm not sure, but again, I'm not claiming that's optimal, okay? But that's what's done right now. And I'll look at Susie to make sure I got that right.
It's somewhat artificial because DOE wants us to allocate in core hours, right? But we charge by the node because only one user can be on the node at the time. So we have to kind
that's
of
a good point.
have this bridge there. So if you get allocated the core hours, but when you're using it, you get charged by the node, and the node adds the GPUs. If you're not using the GPUs, you're leaving real estate untouched, and so it can be expensive for you.
So if you're not using the cores, if you're not using the CPU, you're still...
You're charged by the node, and the node has both CPUs and GPUs on it. So if you're only using the GPUs, yeah, you're still charged for the CPUs because no one else can use the CPUs while you're on the node. And we don't have that problem too much. We tend to have the other problem where people who are just getting used to the GPUs may not be using the full GPU capacity of a node, and so it becomes expensive for them. But that is an incentive for them to ramp up and learn how to use the GPUs more.
And
Does that make sense?
With the new machine having less nodes, are you worried about one user on one node?
Good question. That has
yeah,
not.
that
We
certainly
haven't
is.
had those discussions
Yeah, I mean,
quite like that yet.
That certainly is a concern. In other words, there are less sort of aggregate nodes to allocate to applications. So, I'm not sure that we're going to be able to sub-allocate a node. Okay, in fact, I'm pretty sure
I don't know how that's going to work.
We are
That's
not.
beyond my pay grade.
Yeah, yeah. Oh, okay.
So I had a different question. I noticed that you mentioned on the new platform is going to be on concrete and it's going to be cooled by a water tower. Can you talk a little bit about, from a facilities point of view, that's radically different than most of HPC centers.
Yeah, I'm not sure I understand what you're saying. Is the system water cooled?
On your slide, you had the fact that the new machine was going to be on concrete floor, not a raised floor.
Yeah, yeah.
You also had that it was going to be cooled by a water tower and not by chillers. And I was just trying to get some insight as to why you guys went in that direction.
Oh, I see. Yeah, this is a slide that the buddy put together. We use cooling tower water for cooling, no need for chillers. There I'm going to have to defer to Buddy in terms of again, this is an IBM system, and I honestly don't know the details of how he and they arrived at the the cooling infrastructure.
If I leave you my card, could you?
Yeah.
Thank you.
Yeah. Certainly, I would say overall, no raised floor and those issues are all good. I mean, it's easier to have that, right? But I'm not sure. I'll find out the numbers for you.
I mean, there's a reason why we've had raised floors for years,
Yeah.
right?
Yeah.
Right?
Yeah.
So Doug, I had a question. If you can think of really long reach out as far as the exascale era, do you think you're going to need an additional computer room facility? If so, in a different format? And also, do you have enough power right now? Or is there going to be issues about getting enough power for exascale?
The current thinking is the exascale system will at least at Oak Ridge will require another upgrade, another in fact in the ECI project for for the systems envision, there's budget allocations for a site prep as we call it, and certainly space power cooling is that. Speaking candidly, I think Buddy would love a new building. Okay. I'm not sure we would need it or we'll get it, but that's something that's going to have to be worked out post summit. Okay, but I think it's fairly safe to say the target for these systems is sort of 20 megawatt. Okay, and right now I'll look at Chris. I think we have that much in our space already. Okay, but there is budget and scope anticipated for us for site prep, and that would include that. But no, there's no, at least at Oak Ridge, there are no plans right now for a new building. I'm just telling you, I think Buddy would probably love that. So.